Krishnek here. I'm our EMEA sales manager and our business development manager at Grace Technologies. With me today, I have my counterpart, Nick Augustine. Nick is a part of our business development team here locally within the domestic office here in Davenport, Iowa. And today we're going to be talking about electrical safety by design. And at Grace Technologies, we look specifically at electrical safety and design as a means for providing alternatives, not only for interacting with live voltage, but verification of both presence and absence of voltage testing as it relates to lockout, tagout, NFPA 70E requirements, UL, Underwriters Laboratory, OSHA requirements, and general electrical safety. So we're always looking at current processes and procedures and trying to find a way to enhance those processes and make maintenance safer, smarter, and more productive. Nick, I'll pass it over to you. I think you had some points before we dived into the nitty-gritty of the webinar.
Yeah, absolutely. Yeah, as Chris and I go around, we're able to hit a lot of different customers and get a lot of feedback on not only our products, but ways that everyone throughout the various industries are designing with safety in mind. So what we wanted to do is bring a few of those questions back and share them with you guys. And so they are common questions that were coming up regarding OSHA, regarding NFPA 70E, 79, UL, designing the 508A, and not only how our products can be incorporated into that design, but how designing to those standards is going to help you have a more efficient, smarter, safer electrical maintenance program.
So Nick, I'm curious. You were just at a recent event, right? You were at ProMat.
Yeah,
in Chicago.
Me and Nick Schultz over here. We're up at ProMat. We had another team at IEEE in Reno, Nevada.
Oh, wow.
The week before. And then you were off in Spain, right?
Yeah, so I was at a Rockwell Partner Network event. So we're a technology partner with Rockwell. Been that way for over 20 years. I think we're pushing 25 years now as a technology partner.
Getting there.
Yeah, and so some of the things that I experience on an international level differ just slightly, right? But as it looks at maintenance and electrical safety by design, generally I look at CE requirements, UKCA, and then up in Canada, we're also looking at CSA Z462.
Yes, and we do work. We have a very international customer base. So a lot of the conversations we have will change depending on whether we're talking to someone in South America, Europe, or North America. So I wanted to share a little bit of my background and how I got into this, because I, unique to Grace, came from a side that was not electrical or industrial. I came over from the fire and life safety side of things.
Yep.
And one of the things I like about Grace is that it has the same core values as what I grew up with in the fire department. If you're familiar with any work through a fire department, your most productive way to go about it is to prevent fires, train, and give people knowledge so that they can avoid situations that bring them harm. Grace is the same exact way. Any electrical safety program is going to want to engineer around those risks.
I find customers are just quick to have their workers suit up in high-cal PPE, expose themselves to that risk, and open up an enclosure and physically perform tests, absence and presence of voltage verification. So I think that ties nicely into what we're going to be talking about today, which is obviously electrical safety by design and looking to make that maintenance safer, smarter, and more productive.
Yeah, absolutely. Because same reason. I could put on fire gear, go inside and pull you out of fire, but it's much more productive for me to teach you how not to start that fire in the first place.
Exactly.
And
that correlates very nicely to the products that we offer here at Grace. Like I mentioned, it provides an alternative and it engineers around risk that you might be exposed to in an industrial environment. Now, again, there's always going to be some inherent risk. If there was a product that just completely eliminated risk totally, I think that there would be a hot market for that.
Yeah, we'll let you know when we get there.
Yeah. Obviously that is always our goal, is to try to eliminate risk. But when we look at our permanent electrical safety devices, our PESDs, ultimately that's kind of where we fall in that risk control of hierarchy, engineering around that risk or substituting it for a lower risk.
So like Chris said, the way that we approach at Grace Safety by Design is looking at a process and saying, how can we make that process safer?
Absolutely.
So focusing on like UL 508A type things, if you're building a cabinet, you're going to want to keep those in mind. The designing with safety in mind. So you want to use the right color wires, the right terminations, UL listed products, the contactors and circuit breakers that work with each other. All those are things that you want to keep in mind. And we're going to go over a few of the details of what those standards are, why we build to them, why we know what they are, and then how our Grace products can fit into them. Because a lot of the questions we do get back are, if I install your product, what's it change for the UL listed on the cabinet? If I make field modifications, what's the process for that? So we're going to get into those questions, answer those for you today, and then we'll have a little bit of a live session at the end where we'll answer any questions that come up during the webinar.
Absolutely. Thanks, Nick. So let's kind of dive right in. So we're going to take a look specifically at our permanent electrical safety devices, PESDs for short, and specifically our check volt. The check volt is a 2-in-1 device that has built-in dual redundant LEDs for visual indication of the presence of voltage. And it also has contact test points that allow for the use of a portable test instrument, a voltmeter, a multimeter, giving you the ability to keep your enclosure door closed and safely and efficiently know whether or not you have power present at your particular piece of equipment. And like Nick mentioned, UL 508A requirements, a lot of our permanent electrical safety devices, if not all of them, I think it's actually all of them, are going to be UL listed. Now that UL listing will range. For the check volt, for example, we're looking at 1,000 volts CUL listing. So that is Canadian and US standard. And again, a lot of customers are looking at integrating this because it's a UL listed device. They may have a UL 508A panel that they're building, and it could be for automation, material handling, water, wastewater, whatever that need could be. But because our product is UL listed, you're able to easily integrate that into a UL 508A panel.
All right. So a lot of the questions that come back is, if I have a 508A panel that was delivered and it's on site, and now I want to add a check volt to it, what is the procedure for that? So a lot of them want to know if you have to get UL to come back out, recertify that panel, which you can. Any one of the nationally recognized testing labs can come out and recertify a panel. Because any modifications you do are going to get rid of that UL listing on there. And all the difference is when you're on site, if the authority having jurisdiction, when they're going through making sure your equipment's ready to be hooked up, they're going to see that UL 508A list on your panel, and they're probably not even going to bother opening that up. But if you do make any modifications, add other UL listed products, all they're going to do is open that up, check through, make sure everything's to that standard, whether it's listed or not on the outside. You can build a UL 508A cabinet without being able to list it. It just saves a little bit of convenience when you're a panel shop that's licensed. You can mark it, save some time in your installation. But installing our product still does meet that standard. It still qualifies to that. So there's going to be, if the need to have that listing on there updated once it's installed, you just have one of those nationally recognized testing labs come out and certify the panel.
Yeah. Well, and another question that comes up quite frequently, shifting the conversation slightly here. UL is a big discussion, and that comes up all the time, right? So a lot of our products are going to be UL listed and meet those requirements outlined within UL. However, another topic that always comes up is NFPA 70E requirements, and specifically the process for establishing an electrically safe working condition. The article that I'm referring to is Article 120.5, and I think we should probably outline the distinction between having permanent electrical safety devices in your industrial environment versus not having them, and what that process will look like depending upon what your current situation is. So let's dive into if you don't have permanent electrical safety devices. So as outlined within NFPA 70E, it's Article 120.5. There is an exception that was added in 2018 that can look at a self-testing device. Now, that is one option. The other option is a contact test must be performed. Now, again, in order to perform a contact test, one must suit up in high-cal PPE that is rated for their equipment, physically open the actual piece of equipment, and use a portable test instrument to test at the voltage source. Now, again, tying back into the general larger electrical safety discussion, that is where OSHA usually finds a citation as it relates to the energy control procedure. I believe that there were a little over 600 violations as it relates to that energy control process. And ultimately, you're exposing yourself to a lot of incident energy and a lot of risk. We tying back to the risk control hierarchy. Obviously, suiting up in PPE is one option, and opening up your enclosure using your portable test instrument to test at the voltage source. Again, that is a compliant method for verification of the absence of voltage. However, there is a lot of inherent risk. So let's take, for example, let's look at our permanent electrical safety devices. So somebody has purchased our check volt and installed it into, let's say, an electrical power distribution panel. They installed it on the load side of that power distribution panel. They're able to quickly and easily visually verify the presence of voltage with the dual redundant LEDs. They're also able to use an adequately rated portable test instrument on the outside of their equipment. Now, that means that the enclosure door is closed and the arc flash risk and the incident energy exposure is really literally nothing. That also reduces the overall requirements for PPE, as NFPA 70E classifies equipment under normal operating conditions. Now, there are some criteria that need to be met with regards to OEM, general maintenance standards. But another classification of normal operating condition is the enclosure door is closed. So you will see a reduction in PPE. We strongly recommend that you follow state and local electrical codes. You can quickly walk up to the check volt device, perform a contact test, testing each phase conductor, phase to ground, L1 to L2, L1 to L3, L1 to ground, L2 to ground, L3 to ground, and ensure that you have truly isolated the power. So again, two different tracks, but two entirely different exposures to incident energy and risk.
All right. And how we take safety by design into that to make it easier for you to incorporate these safety devices. Installation is going to be one of the key things we look at. So, and we'll go through, we talked with our engineering team lead, Eric Norton, which we'll be able to show you a video here coming up. But some of the processes we go through to make sure that this is safe by design, and some of the roadblocks and challenges we come up in product development. But with the check volt specifically, there's only 4 leads coming off of this. You're going to have 1 to L1, L2, L3, and 1 to ground. The installation is very simple, self-explanatory, and it's very easy to check and make sure that you have that installed correctly. When it is installed, you get your visual indication, the flashing LEDs, and that ability to test while still making it safe to touch, safe to brush up against. So I think now would be a good time to kind of introduce Eric Norton, jump into that video that we have. Because we do, when we come back and forth from these shows, we like to regroup and have meetings, share feedback, new product development information goes back and forth. And we want to kind of start recording those for you guys, share some of that information. It's really helpful. It's helpful to me and Chris. It's going to be helpful to all of you guys. And instead of calling you and sharing it one at a time, we decided these webinars might be a really good way to go about that. So I think we're going to jump into a video where we kind of meet Eric, and he was going to walk us through some of the manufacturing process.
Awesome. Thanks, Nick. Hey, everybody. Chris Schneck here at Grace Technologies. Today, we're going to be talking about our permanent electrical safety device, our check volt, and safety by design. I'm joined today with Nick Augustine, a part of the business development team. And today, we're going to be talking with Eric Norton, our engineering team lead. Thanks for joining us, Eric.
Oh, thanks, Chris.
Awesome. So talk to us a little bit about the manufacturing of the check volt, what all went into kind of the thought process behind the product, keeping in mind safety by design and installing into different applications for our customers.
Yeah, sure, Chris. I think it started with we wanted to, we had a current VTS system, and that was installation that took a little longer in the panel. You had to have a rectangular cutout. And then since then, we went to a just a 230 millimeter hole punch out, for that combo, the VTS. And then we wanted to have a simpler solution and incorporate both technologies into the same product. And so what we did is we came up with the check volt, which is bringing the voltage indication and the test point functionality into one device, able to install with a 30 millimeter punch out in the panel.
So the voltage test station, the VTS is what you called it. So Explain just real quick for people that might not be familiar with that product. So I assume that utilizes the Graceport product housing, and then in that housing, there's two separate components, right? The
Yeah.
indicator and the safe test
Yep,
point.
that's correct. You have the voltage indicator and the safe test point like side by side in the same Graceport housing.
Wow. So the check volt does exactly what the voltage test station does, but it's just one simple, easy to use 30 mil knockout.
Yep, exactly.
Wow. Wow. So that makes a whole lot of sense then from in terms of a product development and having that just in one easy to use product.
Right. It saves a lot of
Absolutely.
time for our customers. It's easy to use and it's safe. It's all been designed and tested through UL 61010. It's a product that also has the type ratings. So when we went to design this, we wanted to make sure that it was rated for 4X, 1213, and ingress protection, IP66 and IP69.
So on that, the IP69 rating, is that, I believe that's the first product Grace came to market with that had the IP69 rating. Is that correct?
Yeah, that's correct. It's a high pressure washdown test.
Wow.
It's the ingress protection. And so part of the reason we're able to do that is because our mechanical engineer designed this cap with a pinless hinge and to cover up kind of the side of the face. And so that helps protect on the ingress protection, the high pressure wash.
I see a clear polycarbonate cover there. I assume that it's clear because people need to see the visual indication of the indicator, along with having easy access to flipping it up to perform a contact test. Is that right?
Yep. Yeah, that's correct. You'll see this is a new cap design that we have.
Oh, cool.
So this is different from our previous MT, our original legacy product. And we wanted to incorporate the clear so that people can see the indication as they walk by.
Quick, easy visual indication.
While maintaining their type ratings.
Wow. So even so with the polycarbonate cover closed, that's when all of the ratings would be
Correct.
Okay. Got it.
Can you tell us, Eric, a little bit about when you're using this check volt for an absence of voltage test? Do you need to stick the entire meter inside of there, or is just touching it enough?
Yeah, just touching it is enough. When you have your adequately rated meter, all you need to do is make contact with the test point. So these are a little smaller than our current test point, but it's because in this case we're not using it to hold the probe.
Now, with the check volt, are they going to get a full voltage reading when they use their voltmeter with the check volt?
Yeah, they will get a full voltage reading. There is a bit of a tolerance because due to the impedance of the check volt and the meter, and that tolerance is actually going to change depending on how your meter is rated, right? If you have a 10 mega ohm
impedance
or a 5
in the meter.
mega ohm, correct.
Okay,
correct.
So if you can test with just the voltmeter making contact to that, say if someone was doing that, then walked away, that cap still flipped up. Is there any hazard to me coming up if I put my hand on the face of that check volt? Is it going to be safe for me to touch it?
Yeah, this is touch safe. So that's one of the UL tests that they work through when they certify it to 61010. And then also there's no incident energy at the door, right? So this drops down the amps is like 0.5 milliamp when it drops down to the panel.
Okay.
When the actual cap is down, we do have this the screw right here that requires tool entry. So then only qualified people or people that are supposed to access this are accessing the actual port.
So can you tell us a little bit more about the process of designing this? Like, how long was this a concept that we were working on, and what kind of challenges did you have to overcome as you're progressing down that road with the production?
Yeah, sure. I mean, a lot of it is just coming up to this in a compact package, right? And we wanted to use our existing housings to cut costs.
Yeah.
And be able to, kind of build here. And so part of the challenges were the test points, like coming up with those and having the LEDs pop through the faceplate and being able to see these visually.
Yeah.
And so along with that and our potting process with the epoxy, those are some challenges we faced on the design. So those took a couple iterations.
Speaking on the resistor piece, right? So the built-in high impedance, I believe these are using 164 kilo ohm resistors, and the legacy product are 102 kilo ohms. Is that correct?
Yeah, that's correct. This is 1,000 volt rated.
Oh,
Cat
wow,
3,
1,000 volts.
and then Cat 4 is 600 volt
Wow.
rated through UL. So that was the intention, is to give this a higher rating than our current product. So we wanted to improve on our current product and come up with a more compact solution.
Yeah, absolutely. So talk to us a little bit about kind of lead time on something like this. So you were touched on the manufacturing and the production piece.
Sure.
What does that mean for lead time if somebody, say, ordered 50 pieces of these today?
Yeah, well, typically we build ahead, so we have a safety stock that people can order,
Awesome.
and it'll be available for them. As we work through the product, or the process, this takes roughly like 5 to 7 days to build, with the soldering
Okay.
and our other internal processes, the potting, those type of things.
Can you tell us a little bit more about the design, like specifically the faceplate, what the symbols mean, and then how the LEDs work, how they're visually presenting for when voltage is present?
Yeah, sure. So when you look at the faceplate of the check volt, you'll see 3 red lines and then a green line. And so each of these, as this is hooked up to the bus, you'll have a line for each phase. So you have a line 1, line 2, line 3, and then you'll have a ground.
Ground.
And when this is actually in use, the 3 lights will be lighting up and the ground light will be off. The ground light comes on when you lose a phase in one of the lines. So and then on that, when you're looking at this phase, the check volt, we have our the VAC and the VDC. And what happens is when this is plugged in, you'll see alternating flashing LEDs on the positive and the negative. And what that is that's actually just reflecting the signal of the sine wave for the AC voltage.
Yep.
And then
Makes
on the
sense.
DC, you'll see a solid you'll see a solid LED on the positive side because that's a flat signal.
Sure. Talk to us a little bit about the cap. So again, I know that it's a clear polycarbonate cap, but does that come off? Like, can the customer take that off?
The customer can take this off, but it would have to be uninstalled.
Okay.
So they're able to take it off, and it will come with the cap. The cap won't be assembled typically when you receive this product, and it's really easy to put this on. It's a really cool design where you can just pop the cap into this hinge and fold it down.
Cool.
And then it's designed so that it doesn't come apart once it's installed.
Yeah, I assume that would be the customer's enclosure or like the asset that it's actually installed into.
Yeah. Yep.
Okay.
Correct.
Makes sense.
All right. So on the back side of the product, when it's installed, what's going to be inside the cabinet? Can you tell us a little bit about like the wire gauge, how it's the potting process, and how that's all?
The length of the wire.
Yeah,
Absolutely.
sure. Yeah, the standard check volt's going to come with an 8-foot wire, 14 gauge, UL style 1452, which is PVC extruded with nylon over the PV extrusion to help with the gasoline and chemical resistance. And so that's usually that's a good wire to use in the industrial cabinets. It's rated to 1,000 volt at 90 degrees C, and it's typical for this application.
Yeah.
Specifically on the check volt, can you tell us a little bit about the manufacturing process? Because they're made like 50 feet that way.
Right.
Can you tell us what they're going through as the employees are making these?
Yeah, sure, Nick. On the manufacturing process here, we build it from the ground up, and so we had to implement the quality processes. We had to make sure that our fixtures are actually all designed and made in house for this product. It goes through a few processes, right? We have the wire cutting, we have the soldering to the board, we have assembly, then we pot the piece, and then we package it and ship it, and it's tested throughout the actual process. We validate that the LEDs work and that the circuit's working properly. We test the resistance before and after potting.
Well, we do want to thank you, Eric, for coming on and talking about the check vault, helping us better understand the manufacturing process. It was very enjoyable. We'd like to have you back. So look forward to more conversations we can have about how we can incorporate safety by design into a lot of different aspects of people's electrical work.
Yeah, sounds good, Nick. Thanks. Anytime.
Thanks, Eric.
All right. And are we unmuted? That was Eric, our engineering team lead, going over a little bit of the manufacturing process for that check vault. And if he's one of my favorite little notes off of that is that it takes 5 days, not of continuous work, but 5 days in production for that check vault to go from start to finish. And most of that's just that potting process, the high impedance, making sure that it's going to be safe when you go up and touch it. But 5 days.
Yeah,
to make a check vault.
well, it sounds like there's a lot of quality checks in place as well, which a lot of testing is involved. It's not something that we just produce right away and ship things out. We really want to make sure that we are shipping out quality products. And that, again, ties back to the core of Grace as a whole. With the implementation of these types of devices, I'm sure you probably feel the same way, but I truly believe that we are saving lives by having customers install and leverage these types of devices in their equipment.
Yeah, absolutely. And even more so, it's catching on fast. A lot of you that do follow us month to month, and we thank you for that. But if you've been around, you know we released this product back in December. It just went through UL, December 12th, I think it was, and it's taken off like wildfire. If a lot of our distributors are on here, a lot of our system integrators that install these things, but we did have I think our biggest order so far is 215 pieces.
I mean, I know that I've seen quotes trickle through for thousands of pieces. So, ultimately at the end of the day, there's a lot of excitement, a lot of interest, and we certainly appreciate folks that are specifically focused on electrical safety and making things safer, smarter, and more productive.
Yeah, we have a very intelligent customer base out there that knows that they need to engineer around these things.
Absolutely. We
do there's a couple of different versions of what we can do for add safety to your lockout tagout procedure. One of them is going to be one of our earlier products, the voltage indicator, called an R3W. And that's going to help with your mechanical lockout tagout and verifying when voltage is present in equipment, which is
absolutely
a huge question for safety. Is voltage present? Is this going to be safe to open up and work on? So can you kind of explain how the R3W, the voltage indicator, helps with the mechanical?
Yeah, absolutely. So I think what you're probably trying to refer to in reference is a presence of voltage verification check, or also a bump test. And ultimately, a bump test is something to where you flip a local disconnector, isolate the power, and you have a starter, right? You'll see the voltage indicator illuminate and de-illuminate as you flip that disconnect switch. The bump test requires a push button start, or to try to start the equipment after you've isolated the power. So generally used for mechanical lockout tagout purposes, like you had mentioned, a great redundant purpose product, as it does provide that dual redundant LEDs for visual indication. And if you want to mention some of the troubleshooting capabilities as well that the voltage indicator can provide.
Yeah, absolutely. And a big focus of this is a lot of our customers are having lesser electrically trained personnel go about these tasks. So adding redundancy, adding safety is a big part of what they're looking for. What you're going to identify with that voltage indicator is if you drop a phase, you're going to be able to see that from the outside of the cabinet before you're opening up anything, before you're at any danger. If you're isolating equipment and you have a stuck blade situation, it's going to stay illuminated. You're going to see that, and you're going to be aware of that again safely on the outside of a cabinet. If you get a phase imbalance or anything starts showing up in ground, you're going to be aware of that. You don't have to be an electrician or highly trained to know that voltage indicator isn't flashing the way that everyone says it should be and the way you've seen it every other day that you've worked there. As soon as that's showing something different, you're going to be aware, be able to make that call and stay a little safer, other than finding out through an arc flash incident that something was wrong with your equipment.
And again, just to reiterate, the voltage indicator is used for presence of voltage. We are not solely relying upon a voltage indicator for a means of absence of voltage testing or verification. It's more for those task qualified or non-electrically qualified workers.
Yes, but it helps them electrically troubleshoot. So
absolutely.
It gives you more detail. And so when we spoke about OSHA, the lockout tagout procedure, and the citations that are involved with that.
Yeah, the energy control procedure.
Right? Yeah, a lot of that, it's not just the process, but it's the whole encompassing procedure of making sure you have documentation of that procedure, how the parts play into it. So making sure your employees know that a voltage indicator is there for presence of voltage, not for absence of voltage. And then training. Training is an often cited one as well. There's every so often you do have to go through and document that you've trained your employees on the procedure, on what they're able to do and how to do so safely.
Yep. And that ties in, right? Exactly. I mean, if you're making a modification to your equipment, you're changing your process, right?
Yes.
So when you make that change, people need to be aware and they need to understand how to work with that particular piece of equipment and the change that was made. OSHA, again, ties back to training and communication. I believe there was over 400 different citations for specifically training and communication. So again, make sure when you are making these modifications that you're updating the people that are physically interacting with this equipment and ensure that you don't get cited by OSHA.
Yes, and we'll go through. Chris, can you start explaining some of the ways if you change from a R3W voltage indicator to a product like the check volt, where they're both in one? Who is that going to? You're moving to the electrical lockout tagout world?
Yeah. So that's more geared toward the electrical lockout tagout. So absence of voltage testing. Again, this will tie back to NFPA 70E. I think it would be interesting to run through a live dead live test. We did make a slight modification to that live dead live test, which I think we should highlight. So the idea behind a device like the check volt is that you're able to use a portable test instrument and physically perform a contact test to ensure that you've isolated the power. Now, we took it one step further. So Nick is actually showing here with our voltmeter. Prior to us testing through our device, we want you to test the meter to a known voltage source. Fluke has a portable power device that you can carry with you that you could physically use your voltmeter and ensure that your meter is calibrated and working as it intended. And then we recommend testing it live at the device. Do not isolate the power. Test it live at the device first. Ensure that you're getting a proper reading, and test phase to phase, phase to ground, and then isolate the power. Flip your disconnect switch, test it dead. Again, performing L1 to L2, L1 to L3, L1 to ground, L2 to ground, L3 to ground. Perform that dead test at the actual check volt device itself. And then to wrap up, after you've performed that live dead live test, we want you to test your meter back at that known voltage source again to ensure that your meter is calibrated and working as intended. Again, that is solely for verification of absence of voltage and to know truly whether or not if there's power present.
Okay, and this is not a testing device.
Great question. So I referenced this before. In 2018, NFPA 70E implemented a exception to this absence of voltage test. So what Nick is referring to is a self-testing device. Again, our product does not meet the exception. It doesn't have to meet the exception. It meets the rule that is outlined within NFPA 70E. On top of that, again, you will need to perform an absence of voltage test using a portable test instrument, an adequately rated portable test instrument, to perform that live, dead live test.
Yeah, but the check volt is not a solution for testing. It's a solution for moving the test point to a safe area.
Absolutely.
So like we were saying, normal operating conditions, if that panel's closed, that's a lot inherently safer area to test for absence of voltage than it is by opening a cabinet door.
You absolutely nailed it. That is 100% the intent of the check volt device. Okay, so to kind of wrap up with some of the OSHA restrictions, or citations and kind of requirements that we've seen. So another one is periodic inspection. So we want you to install these devices and use them, but obviously periodic checks and inspections should be performed. That is also where OSHA cites, I believe it was over 300 different citations for periodic inspection. So make sure once you implement this device that you continue to work with it, make sure it's working as intended and that it's wired correctly into your piece of equipment. And lastly, the energy control program that ties back to your documentation and your electrical safety program, ensuring that your workers are interacting with voltage in a safe and an efficient manner and not putting themselves at any inherent risk.
Yeah, absolutely.
So when somebody is performing an absence of voltage test, the device actually has built-in high impedance of 164 kilo ohm resistors. Now, the device, among other ratings that it has, so UL type 12, 4, 4X, it also carries IP66 and 69 ratings. It's IP2X rated, meaning that it is touch safe rated. So that ties back to the built-in high impedance of 164 kilo ohms, the max current that somebody would be exposed to, say, for example, on a 480 volt system. In North America, that is very common. Outside of that, it ranges, 600, 575, maybe even 750 volts DC, even up to 1,000. And some renewable applications, an EV, electric vehicles, we've seen upwards of 1,500 volts. So we are working on some new solutions to fit those applications. But the idea is the max current that somebody would be exposed to is milliamps, which falls well below the OSHA shock severity or shock hazard levels of 5 to 8 milliamps.
Yeah.
Generally, that classifies with the GFCI applications.
So I get the question posed to me a lot during installation. We obviously, people think we need to fuse this, right? To make it safe.
Yeah. So we do not recommend fusing. However, if a state and local electrical code requires it, or if you make a modification to the length of the wire or any modification to the device, you can add fuses. Again, it is not recommended, and fusing is not required with the installation of the check volt device. At that point, it will work as intended. However, you would be testing the load side of that fuse, which is why, again, we do not recommend fusing on the device. And again, the way that it's wired in parallel to your source voltage, and it's not a current drawing device. So again, in terms of an arc risk, there really isn't, and it keeps your enclosure door closed.
Yeah, absolutely. Keep that environment out of there. You're putting all those controls into a cabinet for a reason, isolating that environment. You want to keep it closed. You want to keep the dust out. You want to keep the debris out of there. Hopefully it doesn't look like a rat's nest, but we've all
I've been on a few job sites where it's, you kind of wonder, but yeah, absolutely.
Yeah. So we went through the testing, showing the voltmeter using the check volt. We do want to open it up. If there's any questions from our audience, from you guys that follow us month to month, if you were able to catch the last 2 webinars, I did want to give a shout out to those. We had Bryce and Isabel walk through our Grace Sense, the vibration and temperature monitoring system. If you weren't able to catch that, we do always load these up onto our YouTube channel. So if these are of interest to you and you're not able to make it to these sessions, check our YouTube channel for those videos on demand that you can watch at your leisure. And then last month, we had Shelly go through the hotspot monitor.
Absolutely.
There's nothing like that on the market.
There really isn't. I mean, continuous non-conductive temperature monitoring, great for bus bars, bus ducts, switchgear. I mean, I'm really not aware of a non-conductive solution.
It got a lot of attention at ProMat. So there's a lot of interest in it. Yeah, I think there's 40 of them down in Texas right now working on being installed. 18-point leads monitoring temperatures on drives.
Wow.
So
absolutely, yeah,
a lot of interest in that. But feel free to check out our YouTube channel for those videos, for that information. It's a really good resource that you can share around.
Have a safe and electrical day.